sit down and get some work done. All right? I'm ready for the test. Here we go. Convert to degrees. These are guaranteed test questions, so I'm going to go through each one of them. If you got them right, great for you. If you got them wrong, you need to pay attention so you don't miss these again. These are on your test. Okay, 3 pi over 4. We're going to take out the pi and we're going to put in 180. We're going to do 180 divided by 4, that's 45. So the answer is 135. Does anybody have a question about that? Tan 300. We're going to draw a circle. We're going to go all the way around to 300. And in case you wonder where 300 is, remember this is 270 and this is 360, so 300 would be in between them. Right?
Right.
This angle right here is the critical angle. We call it the reference angle. That's the important one. It would be 60. Because 300 to 360 is a difference of 60. Here's the quiz. We're going to move over right now. Now, the sides of the triangle are root 3, 1, and 2. Root 3 is across from the 60. 2 is the hypotenuse. Okay, here we go. Anything negative. The root 3 is negative. I want the tangent. What's the definition of tangent? Opposite over adjacent. That would be negative root 3 over 1 or negative root 3. Abby and Suzanne, I need to see a pencil in your hand and I need you to see making these corrections. Number 3. We're given that the tangent is negative 3/4. What does this mean? Some of you just totally ignore this, and it's there for a reason. What does that mean? That means you are in quadrant 2. How do we know we're in quadrant 2? Well, it's between 90 and, here, Maya. We'll do this right now. It's between 90 and 180, so that's quadrant 2, because here's 90 and here's 180. So there's my triangle. Now tell me what I know about this triangle. The opposite side is 3 and the adjacent side is 4. Now which one is actually the negative one? 4. The fraction is negative. That means either the top is negative or the bottom is negative. In this case, it's got to be the x, the bottom. Pythagorean Theorem would tell me this side is what? 5. Anybody have a question about that picture? We want to find the sine and the secant.
Can you rewind me real quick? How'd you know the hypotenuse was 5?
Pythagorean Theorem.
Oh, gotcha.
3 squared plus 4
Yeah,
squared.
Gotcha.
Now, on the test, on the practice test, so probably on the real test, you have to find everything. I just picked 2 for the quiz, but the idea is the same. We need the sine. What's the sine? Opposite over,
hypotenuse.
so that would be 3/5. Remember, this is the angle you're looking at, so this is opposite hypotenuse. What is secant?
Hypotenuse over adjacent.
Hypotenuse over adjacent because it's the reciprocal of cosine. Secant is reciprocal of cosine. So the secant is going to be hypotenuse over adjacent, which would be 5 over negative 4.
I don't understand why the use the negative 4. Shouldn't it be negative 3?
It can't, you're going up.
Oh, okay.
Going up. Remember, when you put a negative in front of a fraction, it can be on the top, the bottom, or in the middle.
It just depends on what.
Yep, on the picture, which one is negative. Any more questions about this one? Cosine 283. You cannot answer this question without drawing 283. Which quadrant would 283 be in?
4.
The fourth quadrant? Now, for those of you that are wondering, this is 270 and this is 360. Isn't 283 somewhere in between?
Yes, I am.
Now, you don't need to know any numbers. All you need to know is positives and negatives. If we are in this quadrant, tell me about this side, positive or negative?
Positive.
Positive. This side,
Negative.
this thing. There's the signs, right, the SIGNs? Now, I am asking about the cosine. What's cosine?
Opposite of hypotenuse.
No, it isn't. Adjacent over hypotenuse. So here's the angle. Cosine would be this over this, right? So what are you going to have? Positive.
Yeah.
And those of you that explained it by saying in quadrant 4, adjacent is positive, right on. That's it. That's the key. X is positive in quadrant 4. That means the cosine will be positive. Those of you that said negative need to rethink. What was your reason for saying that? Yeah. Okay. And then we have this question. Now, we're going to sketch this because on your test you're going to have to sketch. All right? And we'll talk about period and amplitude also, but we're going to actually sketch this one. So pay attention. Let's work together. There are 3 shapes that you absolutely have to know. You have to know what a sine, cosine, and tangent look like. This is the picture of a sine curve. These are the normal labels. This is a picture of a cosine curve. It has exactly the same, normal labels. Now we are graphing a cosine. But what do you notice about that cosine? There's a negative in front of it. Now, again, just do this at the bottom. You didn't have to do this on your quiz, but you have to do it Friday, so I want to practice it. I'm going to turn this picture upside down, which means instead of starting at the top of a hill, it's going to start at the bottom of the valley. And there's a 2 out here, which tells me that it is twice as tall. So it goes up to 2 and down to -2. That's called its amplitude. So the amplitude of this curve is 2. Not -2, 2. How high are the hills? How deep are the valleys? 2. Because of this number. Now, this number divides the period. What is the normal period of a cosine curve? 2 pi. This one has been divided by 1/5. Dividing by 1/5 is the same as timesing by 5. So this is actually 10 pi. This picture ends at 10 pi. Everything got times by 5. This number divides the labels. So instead of just being pi right here in the middle, what is that label going to be? If it got times by 5, it would be 5 pi. What would this one be, the first one? 5 pi over 2, you're just timesing it by 5. What would this one be? 15 pi over 2, very good, you're just timesing it by 5. And that would be a picture. All you had to do was list the amplitude and the period. There they are. This number multiplies the amplitude. This number divides the period. Okay, who ran into an issue last night with your practice test? Did anybody have an issue with the practice test? I'm looking at practice test number 1, Maya McCoran.
The graph.
Okay, I just did a cosine, so how about if I do the tangent and the sine one? Okay, so I'm going to do the sine one first. Did I turn that on?
Yeah.
Okay, good. All right, I'll do the sine one first, since I have my sine picture up here. So, anybody paying attention, this is 7C. Now, it's a sine, so this is the shape I'm keying on right here. But, just like the last one I did, there's a negative out there in front. What does that mean when there's a negative out there in front? It turns it upside down. So instead of drawing the hill and then the valley, I will draw the valley and then the hill. Furthermore, instead of going up to 1 and down to -1, which is what a normal sine curve does, this one's going to go all the way up to 3 and down to -3. So his amplitude is 3. Now I know what these labels are supposed to be. But this number right here is going to change them. What is that number going to do? It's going to divide them all by 2/3, which means times them by 3/2. So my normal period is 2 pi. But this has been divided by 2/3 or times by 3/2. Now I want you to look right here, kids. This is the key. That means that every single one of those labels right here is going to get times by 3/2. This tells me I'm going to times by 3/2, times by 3/2, times by 3/2, times by 3/2. Now when I find my period, which is 3 pi, because that cancels, that actually does the last label for me. That's 3 pi. That's my period.
Wait, and you know, just run back. You
But
know
to
that's
find all the rest of the labels, I am going to multiply each one of these by 3/2.
so. How did you know that that was 3 pi?
Because the normal period is 2 pi. When I multiply 2/1 times 3/2,
Gotcha.
I get 3.
Gotcha. Okay.
Now, I'm going to multiply each one of these by 3/2. So when I multiply by 3/2, I get 3/4. When I multiply by 3/2, I get 3/2. When I multiply by 3/2, I get 9/4. And I've already done the last one, so I'm done. That's my picture. This number divides the horizontal. Since it's a fraction, dividing by 2/3 is the same as multiplying by 3/2. So every horizontal label got times by 3/2. The period is 3 pi. the last one.
Period's always the last.
Period's distance from beginning to end. So yes, in a sine curve or cosine curve, it'll be the last one. Now, the tangent is all different. That picture is entirely different. It isn't a wave. You'll remember that the tangent is a squiggly line from negative pi over 2 to positive pi over 2. That is your regular, normal tangent.
Don't even answer that.
That is the picture of the tangent. That's in your notes. We went back through that a long time ago, well, not even that long ago. That's the basic picture. Now, what does putting this number out in front? Think about the two ones we just did, the sine and the cosine we just did. What does that number out in front do? Stretches it. What it did over here was it made the hills higher.
It's going to make this one taller.
Well, you can't really make it taller because it goes up forever and ever anyway, but it does kind of straighten it out a little bit. But does anybody remember, we talked about this, does anybody remember what I said about it?
Makes it narrow?
I actually told you you didn't even have to worry about it. It stretches it out, it does not make it narrower. It doesn't change the horizontal, the labels are still here. What is the only way to change the horizontal? You have to put a number here. Does this one have a number here?
No.
No, it does not. So the horizontal hasn't been changed. The horizontal is the same. Are there any vertical labels? No. That's why I told you don't even need to worry about that too. Just graph a regular tangent curve. It is stretched. But it's hard to see when we're just sketching without graph paper. Anybody else have a question about this practice test? There is no amplitude. Tangents have no amplitude. The amplitude is the height of the wave. You have no waves. So there's no amplitude, and the period is still pi. The distance from here to here. The period of a tangent curve is pi. Always. Well, unless you put a number in it. This number right here will change the period, but there's no number in there. The period of a regular tangent curve is pi. Okay, we need another question from the pretest. Olivia? 9F. This is a remember the second page is all calculator stuff. So this is a calculator
Taylor has a
problem.
question.
In order to put this into my calculator, how do I put a cosecant in again? 1 over sine. So I'm going to press 1 divided by sine, and then I put 15 degrees, 19 minutes, and 11 seconds. And where do I find the degree mark? Second angle. Where do I find the minute mark? Second angle. Where do I find the seconds mark? Alpha plus. Now, this is a degree problem, so how should we have our calculator set in the mode?
Second.
It should be in
Alpha.
degrees. All right. Yes, we can do number 12.
Is this right here?
Find the exact value and the calculator value. So we're doing both here with this one. All right, let's cover this up for a second. Let's just look at this. What does this always tell me I'm looking for? An angle. this is the notation. When I use that notation, or when I press that button on my calculator, I am finding an angle, right? So this part of the problem is talking about an angle whose tangent is 2/5. Does that picture look accurate? How come I put the 2 there and the 5 there?
Because it's tangent and it's
Opposite over adjacent, that's right. Now I'll use my Pythagorean theorem and I can find the third side. All I'm doing is drawing a picture of this angle. So let's see. 25 is root 29. So this is a picture of this angle. Kids, we've said it a zillion times. That notation means find an angle. So this is the angle whose tangent is 2/5.
The little thing that you did in your head, you squared the 5 and the 2, right? Okay. I was just making sure, because you know.
Pythagorean theorem. Now, what do I want to know about that angle? I want to know its sign.
Oh.
Can I tell its sign from this picture? What would the sign be?
Positive.
2 over root 29?
Oh.
Opposite over hypotenuse? Or 2 root 29 over 29? So by hand, this is how I would do this problem. I draw a picture of the angle. There it is, I got all the sides. And then I look at its sign. If I'm doing this on my calculator, I just press these buttons exactly like they are. So I press sine, second tangent, 2 divided by 5. And that will give me a decimal that is the same as this fraction.
Did you just like pick up, could you have drawn the triangle on the other side?
No, this is positive. Anytime they're positive, I draw a quadro 1.
Wait, so why do we do 2 over root 29 again?
So it's the
Because it's asking me for
Sine.
the sine.
Okay, gotcha.
yeah, for one. And then the decimal value.
This was a 2-part question. It said find the exact value, that's this one. And then find the decimal value, that's just typing it in on your calculator. They look different, but they're the same number. All right, who else found a question on the sheet that you have a question at? Who else found a question? Ethan?
What was it, 5, E?
5E says find the angle whose sine is negative root 3 over 2. Now how do I know I'm finding an angle? That's this notation right here. This says you're looking for an angle. All right, so I'll draw a picture, see if I can figure out this angle. That's a negative sign, so it's going to be down here. And the sine, which is opposite over hypotenuse, is root 3 over 2. Now you can do the Pythagorean theorem, but you ought to recognize these two numbers and know this side has to be 1. But if you don't, you can do the Pythagorean theorem and it will turn out to be 1. Now, this problem didn't really even ask me for the angle, but it wanted to know the sine. This one wants to know the angle. What is the angle? So what is this angle right here? That's the answer to the question. What is it? Well, it's not 60.
30.
It's negative 60. Why is it negative 60? Because it's going down. So the answer is negative 60 degrees. F is exactly the same scenario, except it's an inverse cosine. We're finding the angle whose cosine is. So that's in quadrant 2 because I need adjacent over hypotenuse to be negative. So again, you can do the Pythagorean theorem, but you should recognize this side has to be 1. And this angle has to be 45. But remember, our angles are measured from here. So that's really gonna be the answer. So how big would that be? That will be the answer to the question. It'll be 135.
Wait.
So the answer is 135.
How is? Oh, okay, got you. Okay, things are making.
Maya?
Are you supposed to know that's in quadrant 2 and not quadrant 4?
Because the adjacent side has to be negative. In quadrant 4, the adjacent side would be positive. Huh?
Quadrant 3.
Nothing's ever in quadrant 3. When we find angles, we never find them in quadrant 3. They're either in 1, well, all the positives are in 1, and then some negatives are here and some are here, depending on whether you want opposite or yes. Not with this notation.
So if that one was negative 60, we didn't change it. Why did we change it? I don't understand why we changed it.
Because we have to start measuring from here. Can I start negative 60? Is this where negative 60 starts? This is where your angle has to start. It doesn't start over here. It has to start here when I measure it. I have to begin here.
Why didn't we subtract 4 maybe?
Why would I do that? 180 is over here. This angle's right here. It's in a whole different place.
Oh, so it's moving this way.
The angle has to begin here. So you've got to get to your, this is the angle, you've got to get to it from here. So I can get to this by coming straight down. The only way to get to this is to come around like this to get there.
And you went down the cut.
What?
You went down the cut.
Yeah.
Because I had to get from here to this angle.
Does it?
And that was the most economical way to do it. The fastest way to do it.
But I'm trying to figure out how you know that you go down versus going forward.
Instead of going all the way around like this, you mean?
But wouldn't it be 60? Oh, because the negative.
All right, anything else?
The
Patrick?
answer also been 300 or
300 remain the same angle in the same position, but it would not be full credit, it would be almost full credit, but the actual correct answer to the problem is negative 60. We want the smallest angle we can get, the smallest number that will generate that angle when we're finding an angle. Now, if you type this in on your calculator, it will say negative 60 if you're in degrees. So, if you put 300, I would not mark that completely wrong, just a tiny little bit. Which one? Which one am I doing? 11. Draw a course of 118 degrees. We talked about this one day. This is different. This is not starting here. Where do we start if we're doing a course? That is with a compass. Where do we start our angles? North. And which way do we go?
to the right.
Clockwise, right? So if this is 0, this would be 90, and this would be 180.
Yes, ma'am.
Now, kids, that is not how we normally do it. That's how we do it only
With a compass.
with a compass. So when it says a course of 118 degrees, we have to go past 90, so that would be a course of 118 degrees.
Okay, I got you.
You never, ever, ever use these labels. These labels are wrong unless it's on a compass. But if it's on a compass, those are the labels you have to use. All right, anything else from that practice test?
So is that all we do for that one? Is just draw the
Yep,
line?
just draw it. Okay, let's look at practice test 2 then, which is tonight's homework.
Oh, no.
And let's start with the graphs,
Are we for real
since
gonna
there was
ignore
some
all these
confusion
more
with
that's
that.
Oh, it's
And we'll see what else to do after
I
we
mean,
do
it's not that
this.
hard. We're not gonna ask like a single.
So, on your test, Friday, you are going to have to sketch a sine, a cosine, oops, and the tangent. So let's sketch one of each right now. This is practice test number 2. Now, I always give myself a little reminder of what the normal curve looks like.
Are you doing like a problem?
I am doing the graphs on practice test number 2.
Okay, gotcha.
And I always give myself a little reminder of what the basic curves look like. Now, we covered these, and like everything else, my expectation is you're learning stuff as we go. If you have not learned this, and you want to pass the test, you will learn it. Because you have to have these basic curves down before you can start graphing the funky stuff. These are all in your notes. We did every single one of those. I'm not gonna have time. We'll work on these. We'll go over them tomorrow again. Tomorrow is our last day, though, before our test. Those of you who have a makeup quiz, why don't we shoot for tomorrow morning before school so that I have a chance to grade it and get it back to you before the test?
Yeah. Can we retake?